Right, we have this particular equation to solve the sine of x plus 60 degrees equals the cosine of 1/2 x. And we present a solution to this particular problem, but in a step-by-step fashion as follows. Right, we have been given here the sine of x plus 60 degrees. And this equals the cosine of 1/2 x. We're interested in finding solutions in the interval minus 60 degrees and 300 degrees. And so to solve this particular problem, we use a reduction formulae. Let us convert the sine to cosine and use the fact that the sine can be converted to the cosine in the following manner, where we put 90 degrees minus open bracket x plus 60 degrees. And this equals the cosine of 1/2 x. 90 minus 60 is 30 degrees minus x. So this becomes exactly 30 degrees minus x, and it is cosine of 1/2 x. Right, upon careful examination, we're able to see that therefore this is going to become 30 degrees minus x is equal to plus or minus 1/2 x plus 360 degrees times k, where k is an element of the set of integers, like so. Now, this is true because the cosine function is an even function. It's an even function, so at this point we get plus or minus. Right. So, and this means what? It means two things. So we're going to have the positive and also the negative cases. Right. So we have 30 degrees minus x equals 1/2 x plus 360 degrees times k, or 30 degrees minus x is minus 1/2 plus 360 degrees by k and z. And now the half x can be transferred to the other side, to the left, giving us minus 3x over 2 is equal to minus 30 degrees plus 360 degrees by k, or now you also have, let's just draw a vertical line here to separate. Right now, if you transpose the minus half, it becomes, when added with the minus x, we shall have therefore minus 1/2 x is minus 30 degrees plus 360 degrees times k, where k is z. Okay, you solve for x, and therefore we divide by minus 3 over 2, or we multiply by the reciprocal, that is positive, or that is in fact negative, and we then get 20 degrees here plus 240 degrees by k. You do the same here. You multiply by -2, both left and right, getting 60 degrees. Plus 720 degrees by k. K in the integers. Now, upon careful examination, we are interested in finding solutions that are in the interval -60 to 300 degrees. So it is clear at this point that when k equals 0, we substitute here. 240 by 0, it's 0 plus 20 is 20. Hence, this is 20 degrees. Here, when k is 0, 0 by 720 is 0 plus 60 is 60. So we also have that x is 60 degrees. Or here, when k is 1, we shall have 1 times 240, which is 240 plus 20, which is 260. So we also have that x equals 260 degrees. And so this becomes a solution. This is a solution to the problem, and we are done. However, there are also other approaches to this. Let's look at method 2. Right, we are still considering the same problem of x plus 60 degrees, but looking at a different approach. And it is exactly the cosine of 1/2 x. And this can be done by writing the sine of x plus 60 degrees, which is exactly the same as the trigonometric sine of 90 degrees minus 1/2 x. And we agree, therefore, that you're going to have solutions in a couple of quadrants. So let's look at quadrant 1. Quadrant 1, where now 90 degrees minus x is in quadrant 1. So this is going to give us x plus 60 degrees, which is exactly the same as 90 degrees minus 1/2 x plus 360 degrees times k, where k is in z. And therefore, now you bring the -1/2 to the other side, giving us 3 over 2x, which equals the 90 minus 60, which is 30, plus 360 by k, k in z. And we proceed to simplify these and divide or multiply by the reciprocal of this particular expression. Right, so we divide by 3 over 2, or we multiply by 2/3. And this is going to give us, for example, if you multiply 30 by 2, you get a 60. You divide 60 by 3, you get a 20. So that means x is 20 degrees plus, same thing here, which is 240. K in z. Okay. So this is a solution in quadrant 1, but we can get another solution in quadrant 2. Yes, because let's look at what happens in quadrant 2. Right, in quadrant 2, then, because the sign for this 90 minus is in the first quadrant, making this positive, and therefore the sign is positive. So in the second quadrant, we shall use x plus 60 degrees. So we're going to write here x plus 60 degrees. Right, so here we write x plus 60 degrees, which is 180 degrees minus 90 degrees minus half x. 90 degrees minus half x plus 360 degrees by k, where k is an element of z. This gives us x plus 60 degrees, which equals 180 minus 90 is exactly 90 degrees plus 1/2 plus 360 degrees by k in z. So we have x minus 1/2, which gives us exactly 1/2 x. And we have here clearly 90 degrees minus 60, which is 30 degrees, plus 360 degrees by k in z. Multiply through by 2, both left and right by 2, obtaining 60 degrees plus 720 degrees by k, where k is in z. Right, we obtained those solutions in those two quadrants, and we shall write a summary. And say therefore, hence we have x equals, right, in the first case in quadrant 2 is 20 degrees plus 240. Is 20 degrees plus 240 degrees by k in z. X is going to be, in this case, 60 degrees plus 720 times k in z. So this is exactly 60 degrees plus 720 degrees times k in the integers. And now, thus it follows that x equals, remember that our interest is in finding solutions that lie in the interval minus 60 degrees up to 300. So which means that here we shall have the following solutions. Thus, x is 20 degrees, right? When we put k equals 0 here, 0 by 240, you get 0 by 240 plus 20 degrees is 20 degrees. Here, if k is 0, you have 0 by 720, 0, which is 60 degrees here. $60. So here, k is 1, gonna be exactly 260 degrees. And therefore, that presents another solution, but it is the same as the previous solution. Now, here we went on to use method 2 to solve the problem. We used method 2 here. And in the first case here, we actually used method 1. We used method 1 here to solve the problem. Right. And we are done solving this question over the required interval. And therefore, we are done solving this particular question. Yeah, a very exciting opportunity to display our skill and potential. Thanks everybody for watching and for joining us, and goodbye to you.